Hello, welcome back to JD Science Prep. Today we are going through some stoichiometry practice questions. I do have a prior video that goes over a little bit of a lesson and gives a more in-depth explanation. So if you are looking for a lesson, head on back to that video. And remember, if this helps, please like and subscribe. So let's jump into question 1. It says, how many moles of sodium chloride would be made if 1.2 moles of chlorine gas reacted with excess sodium metal? So here we have our chemical equation. So let's go ahead and balance this first. It looks like we're going to have a 2 in front of sodium chloride, a 1 in front of chlorine gas, and a 2 in front of sodium. So let's underline some things that we're looking for here. It looks like this question wants us to find moles of sodium chloride, and we are given 1.2 moles of chlorine gas. So I'm going to label this as my A substance and sodium chloride as my B substance. So let's go ahead and start with exactly what we know. So we know 1.2 moles of chlorine gas. So I'm going to go ahead and write that down. So 1.2 moles of Cl2 with a time sign line. And on the top is the unit that we want to end up with. And in this question, that is moles of sodium chloride. So remember, when you're going from moles of one substance to another, you're going to use those coefficients from your balanced equation. So since we want moles of NaCl, I'm going to put on top 2 moles of NaCl and 1 mole of Cl2. And again, I got that from my balanced chemical reaction. Okay. Now, that looks like it's the only step. Our moles of Cl2 will be crossed off, and we are going to be left with moles of NaCl. So we can go ahead and write our answer, 2.4 moles of NaCl. That is going to be our final answer for this question. Our sig figs also look good. We have 2 in our question and 2 in our answer. Let's move on to number 2. All right, number 2 says, what volume of hydrogen gas would be created if 2.3 grams of lithium reacted with excess water? And this reaction is at standard temperature and pressure. So first off, again, let's balance this equation. Just a quick tidbit as well. If you don't know how to balance, go ahead and check out my video on that as well. So we have our balanced chemical equation here, and we also already have our molar mass of lithium, which we will need. I have a video on that as well if you'd like to take a look at that. So in the question, it looks like we are given 2.3 grams of lithium, and we are trying to find volume of hydrogen gas. So lithium is going to be my A substance, and hydrogen gas is my B substance. So I'm going to start with what I know. I know from the question 2.3 grams of lithium with a time sign line. So my first conversion is to go from mass of lithium to moles of lithium. So that's where we're going to use our molar mass. We have to divide by our molar mass. So we have 1 mole of Li on top. And for every 1 mole of lithium, we have 6.94 grams of lithium. So that's our first conversion. If we were to stop here, we would be in moles of lithium, but we want to eventually get to volume of H2. So before we get to volume, we have to convert to moles of H2. And remember, when we're converting between moles of one substance to another, we have to use those coefficients in our balanced equation. So for every 1 mole of H2, we have 2 moles of lithium, and finally we have 1 more conversion. So when you're converting to volume, if you recall, you are going to have 22.4 liters of a gas for every 1 mole of that gas. And remember, that only applies at standard temperature and pressure. Okay. All right, now in your calculator, you would type in 2.3 divided by 6.94 divided by 2 and multiplied by 22.4. And what you should get as a final answer is 3.7 liters of H2. And sig figs also look good. In our question, we're given 2. In our answer, we also have 2. This looks great to me. And just make sure our units cross out here. Moles of H2 crosses out, moles of lithium cross out, and grams of lithium. We are left with liters of H2. Let's move on to number 3. All right, in this question, it says, in the reaction between potassium iodide and lead 2 nitrate, how much potassium iodide is required to create 7.9 grams of lead 2 iodide? So when it says how much, I'm going to assume it means mass. So we're going to go from mass of lead 2 iodide to mass of potassium iodide. Okay, so my A substance is going to be lead 2 iodide. So I'm going to label that as my A. That's my starting point. And I'm going to label potassium iodide as my B substance. That's where I want to end up. So as per usual, we need to first balance this chemical equation. I'm going to start with a 2 in front of potassium nitrate, which means I need a 2 in front of potassium iodide, which means I need a 1 in front of PbI2, and finally, I will need a 1 in front of lead 2 nitrate. So we have our A and B substances. Let's start off with what we know. So we know 7.9 grams of lead 2 iodide. And before we go to mass or moles of potassium iodide, we need to get to moles of lead 2 iodide, which means I will divide by that molar mass. So on the top, I'll have 1 mole of PbI2, and for every 1 mole, there's going to be 461.01 grams of lead 2 iodide. If I was to stop right there, I'd be in moles of PbI2. But let's get to moles of potassium iodide next. Remember, that's where we're using our molar ratios or our coefficients from our balanced equation. So on the top, from my balanced equation, I have 2 moles of Ki for every 1 mole of PbI2. And finally, I'm trying to solve for mass of Ki, so I need to multiply by the molar mass of Ki, which is 166.00 grams of Ki for every 1 mole of Ki. And if you were to type this in correctly, let's try and get a final answer here. You would get 5.7 grams of PbI2. All right. Okay, that is the video. Again, if it has helped, please like and subscribe. Thank you very much.